Good evening, everyone. My name is Liang Chen. I'm from Indiana University, Bloomington. I worked with Dr. Kun Duan, who is now with GE Global Research on this MIDI-Assisted Egocentric Optical Music Recognition project. So basically, we want to use a wearable device, such as a Google Glass, to detect and automatically recognize the music scores. There are a bunch of interesting applications that can be built based on our proposed algorithm, such like we can assist other people to do the sight reading. We can design interesting interactive egocentric games on the wearable device. There are many challenges in this problem, such as the dynamic environment, the image degradation due to noise and the motion of camera. But I think the most difficult part is actually still the optical music recognition part. It's how to interpret the music. So, given the state of the art of OMR, we think it's still not possible to directly apply any OMR software to solve this challenging problem. There are many difficulties that impeded the development of OMR, such like there exists a long tail of rare symbols. It's hard to interpret the 2D layout of music symbols. And it's also very difficult to interpret the music. So, how to solve this problem? Our idea is actually to combine the power of computer vision technologies and offline music data. So we want to fuse the symbolic music data into the recognition process. In this way, we can better constrain the problem and convert the recognition problem into a matching problem. And then our objective becomes to build a model that can more smartly incorporate the symbolic music data into the recognition process. Our system consists of three major steps. The first one is score region localization, and then the staff line detection, and finally it's the note sequence recognition. Each step is dependent on the previous step. For score region localization, we treat it as a foreground-background separation problem. We use a Gaussian mixture model to represent the data likelihood, and use a very strong shape prior to constrain the problem. For staff line detection, we use this sampled pixel triplet to propose staff model hypothesis, and use global votes to evaluate each of these models, and finally use the greedy algorithm non-maximal suppression to prune out the less possible models. For the node sequence recognition part, we build this graphic model to incorporate the symbolic music data into the recognition. Our model is actually constrained by the note sequence, which is passed from the MIDI data. And also, at the same time, it contains a latent attribute layer which models the uncertainty in the transform from symbolic to the music notation. We formulate our matching problem as using a linear chain conditional random field. The unary term is actually trained via linear SVM and using hog image features, and the pairwise term is actually a hard constraint which penalizes impossibly short distance between adjacent nodes. So from the evaluation result, we see our model actually achieved the highest accuracy rate. And below the evaluation table, there are some qualitative results generated from the inference. So thanks for your attention.